Hey there, fellow process engineers. If you've ever spent your afternoon chasing down wonky valve positions or unexplained process hiccups, you know just how much rides on a reliable current to pneumatic, or IP, converter. These little boxes are the unsung heroes that translate our control signals into real-world movement, but man, when they act up, it's a headache. So let's break down the most common problems I see with IP converters, and what you should be looking out for. First up, air supply. Dirty, oily, or wet air is a killer. If your compressed air isn't clean, the internals of your IP converter can get clogged, nozzles get gummed up, and suddenly your valve isn't moving. Or worse, it's moving unpredictably. And don't even get me started on supply pressure. Too high, too low, or just plain unstable. That's a recipe for output that's all over the place. Electrical issues are another classic. If your input current isn't right, say it's not landing in that sweet 420 milliamp range, you can't expect good output. Wiring faults, loose connections, or even ground loops can drive you nuts with sporadic or incorrect operation. I've lost count of how many times a simple wiring check would have saved hours of troubleshooting. Mechanical wear, yeah, it happens. Over time, diaphragms can crack, seals can leak, and orifices get blocked. Even a tiny bit of contamination can send your pressure readings out of whack. And if your device isn't holding pressure, look for internal leaks or a worn-out diaphragm. Don't forget about calibration drift. IP converters aren't set and forget devices. As components age or if temperatures swing wildly, you'll see your output pressure start to wander. If your system's acting up and everything else checks out, it might just be time to recalibrate. Let's talk about the environment. Mechanical vibration can shake things loose or mess with sensitive parts. Corrosive or humid conditions, those will eat away at your internals way faster than you'd like. And if your converter uses magnetic components, nearby electrical panels or big motors can introduce interference, something I've seen plenty of times in crowded MCCs. Performance quirks show up as non-linearity, slow response, or hysteresis, where the output lags or doesn't return to the same point. Often these issues are downstream effects of everything I've mentioned: poor air, bad wiring, aging parts. So if you're seeing no output, drifting signals, or delayed response, don't just swap the IP and hope for the best. Dig into your air supply, check your wiring, inspect for leaks, and don't skip the calibration. A few minutes of focused troubleshooting can save you a plant-wide headache, and maybe even your weekend. That's it for today. Keep those converters clean, calibrated, and connected, and your process will thank you. Catch you next time.